let's walk up to the next stage,
Yeah.
which has this beast called NP. What is the NP complexity class?
Good. So NP stands for non-deterministic polynomial time. Okay. I should caution people, it does not mean not polynomial. Okay. It's something much more subtle than that. Okay. So NP is basically the class of, you can think of it as the class of all the problems for which if the answer is yes, then that can be efficiently checked. Okay, so it may be very, very hard to find a solution, but at least once a solution is found, then that solution can be efficiently checked. So formally, the way we define it is, again, it's a class of decision problems, but now we introduce an asymmetry between a yes answer and a no answer, okay? And we say that if the answer to the decision problem is yes, okay, then there has to be a short witness. Okay, what does a witness, what does short mean? Short means of size that is at most polynomial in the size of in the number of bits of the input, right? And that witness has to be efficiently checkable. So
it can be verified in polynomial time.
Exactly. So there has to be a polynomial time algorithm that for every yes input, will accept when it's given some witness. Whereas for every no input, there is no witness that causes it to accept. So since that's, kind of abstract, it'll help to give an example, right? So let's take the problem of factoring, right? So, I'll just come back to, one of our favorite examples, right? So, okay, so technically, factoring is a problem, what we call a search problem, right? Like I say, you have to find the prime factors of this number. Okay, but we can easily come up with decision problems related to factoring. Like, for example, does this number have at least 3 prime factors? Does this number have a prime factor ending in a 7? Or something like that. Okay, so imagine we ask a decision problem like that, about some 3,000-digit composite number, right? Now, that problem might take an astronomical amount of time to solve. As far as we know, it does, using any classical algorithm, right? But if the answer is yes, then there is a short proof that the answer is yes. Okay, what is the short proof? The short proof is just I show you the prime factorization, right? And, you can use the fact that primality is in P, so you can check that, yes, indeed, these numbers really are prime. And it's easy to check with your computer that, yes, they do multiply to the original composite. And so in that way, you would verify the answer to this question. Okay, but there are many, many other examples of NP problems that should be familiar from experience. Okay, one would be, let's say I give you the dimensions of a whole bunch of suitcases, and I ask, can these fit into the trunk of your car?
Okay.
Right. Maybe listeners have had to deal with this problem in real life, as I have when going to the airport, right? Where like the trunk will not close. So then you say, all right, but what if I just take all the suitcases out and then I try packing them in a different way?
This
right?
is the version of the knapsack problem.
Yeah. Or we call it the packing problem.
The packing problem.
Yeah. But or 3-dimensional packing, if you like, right? We could also have 1- and 2-dimensional versions of this. But it may be. If you imagine that there were hundreds of suitcases, right? There might be a combinatorial explosion of different packing strategies that you could try. Nevertheless, in the end, it's very easy to check whether a solution is valid or not. Namely, does the trunk close?
Right.
Or does it not close? Yeah. Right. Okay. We could also talk about, I show you a graph of thousands of people on Facebook, and I show you who is friends with who else. And I ask, is there a set of 2,000 people who are all friends with each other? Right. This is called the clique problem. Right. And so again, it might take astronomical time to find that 2,000 clique if it exists. But if someone claims that they found it, then they just have to show it to you. And then it's very easy for you to check whether, are these people really all friends with each other or not? Hey, we could talk about Sudoku puzzles or jigsaw puzzles. They have the same character, right? They might be very hard to solve, and yet in any case, it is very easy to check any purported solution. Okay, so it being easy to check a purported solution, that's the defining property that puts a problem into the class NP.
So the problem itself, finding the solution, might take exponential time, but to verify whether a given solution actually works, that might take polynomial time.
That has to take polynomial time in order for the problem to be in NP.
Perfect. You brought up Dijkstra's algorithm, finding the shortest path between 2 points. The traveling salesman problem would be an example of an NP problem, right?
Yeah. So yet another example of an NP problem would be like, I give you a collection of cities. I tell you the distance between each city and each other. Now I ask, is there a tour that visits each city with, let's say, at most 5,000 miles total? Right. Or, at most this many frequent flyer points or whatever it is. Right. Again, if such a route exists, then you just have to exhibit it. It's easy to check. But if you're not given the route, then there might be, a combinatorial explosion of different possible routes that you would need to check.
Well, Amazon Prime and delivery might be very interested in the answer. Okay, so
they are.
They are.
I mean, they're certainly interested in general in combinatorial optimization. Yes.
I'm sure they're listening. So we've already met P.
I mean, if they've taken undergraduate computer science, then they know this stuff.
Of course they have. We know they have.